Okay, we're recording back. So, with a bit postponing, but still, now we are all in. Elizabeth didn't answer, so I think that we won't be having her today. I don't know. I'll contact you later. I hope she'll write me back to see what went wrong today. Like we said before, today is the first day of our training program, and today is the Romagna Tech that's presenting their thematic areas. So Massimiliano, stage is yours. Just turn on the sound.
Okay, thank you very much. Well, just before sharing my screen, I just want to make a brief introduction on these 3 sessions workshop. Well, as Romagna Tech, we are a member of the cluster CREATE, that is an association of public and private bodies, such as companies, research centers, training institution that are skills, that share skills, ideas, resources to support the competitiveness of cultural and creative industries in Emilia-Romagna region. So the idea of this workshop is born inside this contest, the contest of this cluster, because I am also the chair of the value chain that is called ADDICT, and that means Advanced Design and Digital Craft Technologies. And this value chain deals with, of course, design and manufacturing processes, in particular in the field of cultural and creative industries, and more specifically in the field of industries that deal with manufacturing new products. So we try to share enabling technologies to support design and also manufacturing processes. And so the main topic of this workshop. Well, I know that design and manufacturing processes are closely related to each other, because we need to design before manufacture. But anyway, in this session, in this workshop, we will mainly focus the attention on digital craft technologies and not on advanced design. Also because I think that design tools and methods will be also presented in the next days by other partners. So we are focusing mainly on manufacturing technologies. So this is the main topic of this the first session of the workshop. In the next session, I will focus on what we call continuous mass customization. That is an approach to manufacturing, and in this approach, the digital fabrication has influenced so much the manufacturing processes. So we try to focus on how these technologies can bring to a revolution in the manufacturing processes, opening also new ways in the design approaches. Finally, to close the workshop, my colleague Francesco will focus on the phenomenon of online platforms for co-design and co-production, for co-design, co-manufacturing. So also in this case with a point on the development of new products and services, always in the field of creative and cultural and creative industries. So I will share the screen, but I need maybe some.
You need permission, probably.
Yes.
Yeah? Joanna, could you solve that?
Yes. Yeah. Maybe now you can.
Okay, okay, thank you very much. Okay, sorry. Can you see my screen?
Yeah. Just not in the shared option. Not in the presentation mode.
I'm sorry, do you want to put it in presentation form so we can see just one slide? Massimiliano, is that the problem?
Okay. So first session is about digital craft technologies with a focus on digital fabrication, 3D printing, and additive manufacturing. We see some technologies, materials, and also applications. I told you about the idea of this topic. This topic was developed with the works that we are carry on the cluster create, that is the regional association for cultural and creative industries in Emilia-Romagna region, and in particular with the value chain addict, that is that means advanced design and digital craft technologies. Well, we start with digital fabrication. What is digital fabrication? The digital fabrication is a process that allows us moving from bits to atoms. So we can move from a digital 3D representation of an object, of a product, of a good, and obtain the physical, the 3D physical object from is 3D digital representation. So it is a new innovative processes that we can use in different fields, and this kind of technologies will allow to completely change the traditional manufacturing paradigms for what concern manufacturing. So the first step is mainly to use a CAD software to create a 3D model, or also we can use 3D scanning for 3D reconstruction of an existing object. Or also we can browse in the online repository of 3D models to search something that can could be useful for our purpose. Then we need to move this 3D representation into a physical representation, and there are a lot of technologies, mainly are additive manufacturing technologies, or also subtractive manufacturing technologies that allow us to move directly to the physical object. So this is a very schematic representation of what we mean with digital fabrication process. And a digital fabrication process is the basis from the developing of innovative manufacturing approaches, is the basis for develop new business models, and these digital fabrication processes can push the evolution also of the more traditional activities, such as craft activities, by moving from a traditional artisans to a maker, or to a artisan 2.0, so a digital approach also in traditional manufacturing processes. Well, digital fabrication is an easy and direct production system for building solid three-dimensional objects, starting from digital drawings, maybe also two-dimensional drawings, or 3D models mainly, with innovative manufacturing technologies such as 3D printing, laser cutting, milling machines, so both additive and subtractive technologies. This approach has introduced an important change in the world of the design, a change that is mainly reflected also in the production chain, with new figures that can face with these technologies, and there are makers and artisan 2.0. To 3D print an object, we need, as I told, a digital model that is the starting point, and we can obtain it by means of computer-aided design approach, by means of 3D scanning, or browsing online repository of 3D models. But digital fabrication inverts the economics of traditional manufacturing. I will come back also later to this theme because it's very important for our workshop. In mass production, most of the costs are in front of tooling. So there are a lot of costs to set up the production, the manufacturing lines to produce goods and products. And the more complicated is the product, the more change you need to make, the more it costs. So in this picture, we can say as digital fabrication has a very different reverse approach. So what is expensive in traditional manufacturing processes is not expensive, is free for digital fabrication. So for what concerns digital fabrication, the variety is free, is not a cost, a complexity is not a cost, flexibility is not a cost. While these aspects are very important for what concerns the cost of traditional processes. We said that fabrication and design, the manufacturing and design, fabrication and modeling are strictly linked together, because in digital modeling and fabrication approach, we combine 3D modeling and additive or subtractive manufacturing. Additive manufacturing also can be referred as 3D printing, of course, and subtractive manufacturing is also known as machining or milling. So these now there are just some pictures that show the different approach of this kind of manufacturing technologies. It is important to underline as the additive manufacturing processes allow to a reduction of the waste material, so as also an important attention to the sustainability of the production, instead of subtractive manufacturing that will produce more waste material. Also, we say that complexity, complex geometries are not a limit for these technologies, and we can see a comparison between the same object, or better, the comparison between two different versions of the same object that has the same function. The first is obtained by means of subtractive manufacturing. The second one on the bottom of the picture by means of additive manufacturing. We can clearly see that this kind of design, this kind of result is not possible to obtain by means of traditional manufacturing processes. So we need a new design, and we need new technologies for manufacturing this kind of products. Well, we can see quickly additive manufacturing technologies, but we will have a better focus later, and also subtractive manufacturing, just to have first comparison of this kind of technologies. So just to closing this first introduction, we can say that digital fabrication is a way to move from bits to atoms, to move from informations to materials, from data to materials. Is a way to move from digital to physical. So these interactions between the digital world and the physical world is the basis of the digital fabrications approaches. And a lot of projects are investigating the ways to optimize the interaction between these two representations of the same object. Well, talking about digital fabrication, we can jump back to 1998 to the Fab Lab concept. In the Fab Lab concept, that means the Fab Lab means the fabrication laboratory, and are represent a networks of facilities for digital fabrication. The idea of Fab Lab was conceived by Neil Gershenfield, that is the director of the Center for Bytes and Atoms of the Massachusetts Institute of Technologies. So we find both aspects of the representation of an object, the data representation and the physical representation. And the first Fab Lab started in 2002 at the MIT University, and in the following years, this model of digital fabrication really spread over the world, and this was possible by means of the standardization, the democratization of the design tools, such as rapid prototyping, the digital networking between all the Fab Labs around the world, and also by means of the dissemination of good digital practices. But what is a Fab Lab? Well, a Fab Lab can be described by means of the Fab Charter, that is a sort of agreement amongst all the Fab Lab users. And this chart describes what is a Fab Lab, that is described as a global network of local labs enabling invention by providing access to tools for digital fabrication. So the main spaces in the world that was dedicated to digital fabrication were Fab Labs all around the world. So we have a lot of other agreements for what concern what is in a Fab Lab, that there are a lot of machines, a lot of devices for digital fabrication. Well, the first list of devices of the Fab Lab was basically based on subtractive technologies, and just in a second moment also additive manufacturing technologies such as 3D printing was added. Then what does the Fab Lab network provide? Who can use a Fab Lab? It is important the aspect of the open access for everyone, because one of the important rule of the Fab Lab is the democratization of the technologies of manufacturing. So in this way, we have seen really explosions of Fab Labs all around the world, and I think that in the country of each partner we could find more than one Fab Lab. So I think that for what concerns digital manufacturing and for what concerns networking, I think that are important subject that we can take into account for what concerns also the digital fabrication and the creative and cultural industries. Also because in Fab Labs we can share both creative and technology that are the important key factor to innovate products also for what concern traditional craft approaches. So just an overview of the tools and machines of Fab Labs. We can see some laser cutters and CNC milling machines, and I have just posted some pictures of important step of in the 3D printing evolutions. So the wrap and the maker boot machines that opened the way to the open access also to these kind of technologies. Well, now we can focus on different manufacturing technologies, just having an overview of what we can find in the world of additive manufacturing. We have quite recent, but fortunately we have some international standard that allow us to have definitions, to have a description of the general principles, to have some feedback on terminology and so on. So the first thing that we can read is what is additive manufacturing, how is defined additive manufacturing. Well, there are a lot of definition. We can see a lot of also norms that we can use to refer to this kind of technology, but the international standard states that additive manufacturing is a process of joining materials to make parts from 3D model data, usually layer upon layer, and it is a process that is opposite to subtractive manufacturing and to formative manufacturing technologies. So process of joining materials layer by layer. And this is the definition of this kind of manufacturing technology. Then we have a classification of different families of additive manufacturing technologies. The world of technologies for what concerns this kind of machines is very wide, and this is a very useful guide, and these are very good useful guidelines to have a clear classification of this kind of technologies. For example, here we have the definitions of these 7 families. We also face with some trademarks of companies that are different from these specific families, but that are inside these main groups. If we want to explode these 7 families, we can see how the complexity of technologies is shown by this picture. So there are a lot of technologies, and all of this technology mainly can be used, can be applied for specific applications. So I'll try to show some
Did we lose Massimiliano?
show.
Okay, you're back. Okay. Have you shared computer sound?
Okay, this is the first technologies, the first family, fused deposition modeling. This is the most famous technology. Is very used by makers. It's very easy to find these technologies in fab labs and so on. These videos are showing the working principle. We have some thermoplastic filament that is extruded to build up the model layer by layer. Together with the build material, we can also have support material that is used to support the overhanging parts of the model, such as in this case. Here we can see how this technology is working layer by layer. The different colors represent the different layers of the model. Now we can remove the support material, the white material, and clean the model. This is the final results that allow us also to finish the surface of the model to give an aesthetic, better aesthetic aspect, following maybe requirements of the of the products. And this technology is applied in very application because it's very functional. So can close this and we can move to the second technology that is called stereolithography. This is one of the most used for what concern aesthetic prototypes, because this kind of technologies give us objects that are very nice from an aesthetic point of view, but the mechanical characteristics are not so good. So for functional prototypes is not the recommended technologies. But we know that we can face both with functional or aesthetic prototypes. So we can choose the better support. In the case that the working principle is based on UV resin that is hit by UV laser. So these allow the curing locally of the material. So we can also in this case layer by layer complete the construction. We always need to clean the product. This is a post-processing step. We can see the superficial, the final coating, and this is the final result. Well, we move to another technologies that also in this case is very can be used in a lot of fields of application, and this is called selective laser sintering. In this case, we have a powder that is sintered by means of a laser that hit locally the surface with the powder. So the first layer is created. Then we move to the second one, and so on. All these technologies works by adding a layer of material on the previous layer, and it is important to manage the thickness of the layers to provide better results. So the basic principle, of course, is the same. That is, of course, the additive approach, but all these technologies are based on very different working principle. Okay, we can see some examples of application. Now we have the last two technologies that I'd like to show you. We have the market offers a lot more solutions, of course, but I think that these technologies are the more suitable for this field of application, for what concern the manufacturing in craft activities. This is a polyjet. You can see some toys, some products. We have some inkjet that is dropped down on the material, so that is it allow the creation of the selective creation of the layers. Okay, yeah, the finish. The post-processing steps. Also, in this case, we can have very nice prototypes, very nice objects, very nice products. Well, the last technology is quite different, particularly for concern the material that can be used. In this case, we are facing with a direct metal laser sintering. In the previous technologies, the basic materials was mainly polymers, different kind of polymers, but with this technology we can also build object with metals, different kind of metals. So it is very useful for what concern, for example, the manufacturing of spare parts, so that we don't need to have a lot of stock, and we can just produce on demand. Also, products that are not prototypes, but are products for directly for the market. The process is very similar to the selective laser sintering. The mainly different is the material, of course. In this case, we have metallic powders, and the source that is a laser in this case with more energy needed since we need more energy to synthesize the metallic powders. So I think that's all for what concerns the video, just to have an overview of these technologies. And I'm going to closing this the first part of the presentation by focusing on the materials. We have seen different technologies, we have seen different families, and each technology face with specific materials. We can see that we have polymers, both thermoplastics or thermosets, depending on the additive manufacturing technologies that we use. We can have metals, as we have just seen, but also other kind of materials, such as sand, composites, and so on, but also fine materials such as chocolate for the eating, for food manufacturing, also biomaterials for biomedical applications, and so on. Of course, we can have different results according to the technology that we can use, and we can select the technology according to the basically to the needs of the object that we need to prototype. So the first aspect is the first question is why I need this 3D printed object. Is just for aesthetic point of view, just for communicate in a concept, or I need to stress the object by means of some mechanical test to validate, for example, a design before going into the production steps. So this kind of question allow us to understand and to try to choose the better technologies to obtain the result. And what can we do with this additive manufacturing technology? What can we do with by means of digital fabrication? Here we can see just some examples that I've choose for what concern the field of creative, the field of fashion, the field of also interior design, and so on, also jewelry. So there are a lot of possible application that allow to obtain results that we cannot obtain by means of traditional manufacturing approach. So this technology allow us to change also the design processes. We have seen that the design and the manufacturing are strictly connected because are different steps of the same process for developing new products. And of course, the capabilities of these manufacturing technologies are pulling new capabilities also in the design approach. Now we can print, we can 3D print this kind of design, but by means of traditional technology, this was not possible. So these manufacturing technologies are giving us the possibility to rethink about the design of the objects, to rethink about the shapes, and also we have seen that since we don't have the problem to produce a high numbers of items, we can also focus on customization and personalization of products. So I just put some references for further information, and I will close this first session that was focusing on technologies and mainly additive manufacturing. Then I can move to the second step that will focus on how these technologies are changing the manufacturing approaches, and how these technologies can allow us to provide a continuous mass customizations of products. But of course, if you have any questions or some suggestions, we are welcome, of course.
I'll just ask if you have this equipment in your Fab Lab, or are you renting it to others, to other companies, or is that just filed?
Maybe you are mute.
Sorry, you can hear me? Okay, never mind. I have some technical issues.
Sorry.
We can continue.
Francesco, are you going to continue?
Hi, Massimiliano. Can you hear me?
You're muted. Francesco, you are muted.
Sorry, guys. Here I am. I think Massimiliano have a second part of the presentation. And Massimiliano, can you hear us? You are muted, Massimiliano.
I don't know. Okay.
No. So there are two questions. The first question is from Ian. He was asking if you have these technologies in your Fab Labs, and if you rent these technologies to other companies for projects or something like this. And the second question is from Roberto Ballesteros, and is asking for potential application of these techniques in cultural and creative industries in the 7 subsectors of the project, of the scale project.
Okay, of course, we have some facilities for what concern 3D manufacturing, both for didactical and teaching purposes, but also we are facing also with the setup of a new lab that will be equipped with some professional tools with the aim to support other partners, other startups, or who needs this kind of technologies in this in the work. We have also open to citizens, to everyone, for what concerns this kind of technology, because as I told, one of the I think most important aspect is the possibility of democratization of the manufacturing technologies. So now everyone is could be able to product something without need of an amount of cost for setup production lines and so on. So this is this technology is very flexible, is very cheap for what for who needs just small number of items. Of course, it's not the right choice for mass production, but this is this technology move in the opposite direction with respect to mass production. So this is I think the first answer. For what concern how these technologies can be used, well, we can think about different possibilities. Well, for industries, cultural, creative industries, this technology obviously open a way also to direct product, to direct make products for selling it. It can be used for to support online e-commerce, because by means of these technologies we also can provide a regionalization of the production. That means if I design an item in Italy, I can send the 3D digital model to Spain, to I don't know, to Croatia, and the model can be 3D printed in the places. So we don't need to move the physical object, but we can just move the digital object. And other aspects of production of applications is to support also the day-by-day activities that also cultural groups have to face day by day. I mean that a lot of companies that are involved in performing arts, that are moving into act on theaters, so companies that need to build up some scenes to support a representation and so on, have to face with maybe I can see a unique product. So we cannot find the solution in a mass production approach, but we can design by we can directly design what we need, and we can find the technologies to print it.
Okay, thank you, Massimiliano. If you'd like to continue with your next model.
I go on.
Oh, sorry, Vesna, I ask you something. Are there any negative sides of these technologies, if there are any?
Yeah. Well, I can say that in the last years, and we also see this aspect in the next presentation. We have these technologies improved a lot. So while the first, I think 10 years ago, mainly it was used just for prototyping, so not for obtain a final product of an object. In nowadays, we can 3D print almost anything. So just to say, this technology is used for spare parts in the aerospace industries. So it is used for biomedical applications with the 3D printing of biomaterials. It is used for prosthetics and orthosis design and manufacturing. So there are really a lot of technologies. We are also coordinating a project that is founded by Europe Commission, the European Commission, about the possibility of sharing these technologies with in the field of cultural heritage, and in the field of cultural heritage, but also in the field of creative sectors. And the project is called Supercraft, that is an acronym of Smart Utility Platform for craft for Emilia-Romagna craft. So the aim of the project is to create a B2B platform, B2B processes to facilitate open innovation and to give the opportunities to share this kind of technologies to improve and innovate the product. The drawbacks is that is not so rapid. One of the name of this technology is also rapid prototyping, but it's not so rapid as such as someone could imagine. For example, for an object of small dimensions, I can need also 10 hours. So it's not a very quick response to the manufacturing process, but I save all the effort in terms of cost and time to set up a traditional line production for traditional approaches. So it is the drawbacks is that is not useful for a lot of numbers of items that are always the same. So if I don't customize, if I don't personalize the 3D design, is not so useful. And another drawback is that to better appreciate the capabilities of these technologies, we need to start to change our design approach, because sometimes we see that people still design the same matter, such as it would print by means of traditional technologies, but in this case we don't have the benefits of this technology. We have seen the comparison of the two versions of the same object at the beginning of the presentation, and of course I can 3D print also the traditional design, but it's not so smart choice. So we can better use also the design according to the capabilities of the manufacturing processes.
Okay, thank you, Massimiliano. Now, yeah, let's proceed to your second part.
Okay. Well, now we move to sorry, okay. Now we move to this this term, that is continuous mass customization processes. Well, it's not, maybe it's not easy to understand, so I'll try to do my best to share my knowledge about this approach. The idea is going from the user to the product. So continuous mass customization is an evolution of the more recent approaches on manufacturing, that is the mass customization. And while the traditional process of mass customization is a discrete process, so we are not able to move to continually range between variable of the design. In the continuous mass customization, we don't have, well, we have different possibilities in the design. So by means of new approaches also in the design step, such as generative interactive modeling approaches, we can share with different person, the designer, the customer, and other stakeholders involved in the design process. We can share platform for the design, also for the collaborative design of the product, and we can customize, deeply customize the items we are going to design. Well, I'd like to start this presentation with this cover page of The Economist. It is dated back to February 2011, so it's just over 10 years ago. And the suggestive title of this cover page is "Print Me Stradivarius." That means the manufacturing technologies that will change the world. So what stated The Economist 10 years ago? That well, the Industrial Revolution of the late 18th century made possible the mass production of products. So the mass production that was able to create economies of scale and changed the both economical, social, cultural approaches in that time. Now, new manufacturing technologies such as additive manufacturing is doing the opposite. So, three-dimensional printings makes it as cheap to create single items as it is to produce thousands of these. So it is not connected to the two economic scales. So if I need to create just a few products with this kind of technologies, I can do it. So these technologies, this approach of to the digital fabrication was seen as something that it would be changed also the manufacturing paradigms. So this is a classical pictures of how the industrial revolutions that we encounter in the last years have changed the manufacturing processes. The first, the mechanical production revolution, we can say, allowed the mass production. Then we moved to electric first, and then information communication technologies that are the second and the third industrial revolution. So mechanical, electrical, informatica. So the fourth revolution is now facing with new technologies, new approaches, new possibility of manage both digital and physical things. Oops, sorry. And in this fourth industrial revolution, also known as Industry 4.0, and is very important for what concerns innovation of products, open innovation, digital transformation, sustainability, and so on. We are back to 2015, so 5 years later, the title of The Economist, and this is a report of the Boston Consulting Group that in this paper that is called Industry 4.0, the future of productivity in manufacturing industries, try to identify the technologies, the main technology of the fourth industrial revolution. So within these 9 technologies, we can see also additive manufacturing. So this is just another point in favor to the application of additive manufacturing in industry. Well, additive manufacturing is important because companies have just begun to adopt, we are in 2015, just began to adopt additive manufacturing, such as 3D printing, but not just to prototype something, but also to produce individual components. So the most important step is moving from the prototyping application to the production application. So this is a very important step in this kind of processes. These additive manufacturing methods, Boston Group Technology states that are widely used to produce small batches of customized products that offer construction advantages such as complex, lightweight design. We have seen also before how the designs is a key factor in to obtain good results. So we can also have a look to the hype cycle of Gartner. The hype cycle specifically designed for 3D printing technologies. This is just a graphical representation developed by this American research company for representing the maturity, the adoption, and the social application of specific technologies. So the more on the right we are, the most technology is close to the market, while to the left side of the graph we can see maybe the promising technology, but we don't know if they will effectively will be arrived on the market. So we can see anyway that in that years 2015 different technologies were already on the final part of the graph. That means that we are facing with completely mature technologies. And of course, the first is the 3D printing for prototyping, because as I told you, it was the first application and the most studied market segment. By analyzing this kind of 3D printing revolution, this is an analysis of Christopher Barnett, 2016, 3D printing. He tried to analyze markets and applications of 3D printing revolution. He identified 4 distinct market segments that are rapid prototyping, molds and tooling, digital manufacture, and personal fabrication. We can see that in the top line that represent today in 2021. We have a completely mature market segment that is rapid prototyping, but we have seen this also in the previous graph by Gardner. Also molds and tooling, then we'll see in detail what kind of application refers to, is in a good position. Digital manufacture, the third market, and finally we have personal fabrication that we can see is the last market in terms of starting point, but of course is the most promising, because we have the possibility to increase a lot for what concerns 3D printing adoption. We can say that the rapid prototyping market is quite full for what concerns the adoption of this kind of technology, but we have a big way to run for what concerns personal fabrication. Well, rapid prototyping, it is well known, means use this kind of technologies such as 3D printing to create prototypes or concept models, and mainly this kind of approach, this kind of market segment, this kind of application is developed during the process for developing new products, and are mainly used to reduce the time to market, to reduce the time we need from the idea of the new product to the release on the market, and this kind of technology is also known as a time compression technology. So for the fact that at the aim to shorten, to reduce the time to market, we can provide both aesthetics or functional prototypes. Aesthetics prototypes, also called looks like prototypes, while the functional prototypes are also called works like prototypes, because they have different aims. The goal of aesthetic prototype is to provide physical sample of what the product will look and feel like. So we need, in this case, this is the prototype of, for example, a ring, but the final product will be with different materials. This allows us to communicate the shape, to have a look, a vision of the shape of the object. In the functional prototypes basically has the goal to create prototypes for working exactly as the product that is designed to function. So I need to test the functionality and not, I don't care, for example, about the aesthetics aspect. Molds and tooling, the second market segments, what does it mean? It means that in addition to rapid prototypes, 3D printers have been adopted also to make tooling and molds to obtain prototypes or to obtain products. So it's not still used to obtain the final product for the market, but is used to obtain the tooling items that we need in the process for developing the final product. And we can face it both with direct tooling, that means rapid prototyping is used to make the tool itself, for example, in this case, the mold, or indirect tooling. In this case, a pattern that is also called a sacrificial model is created by rapid prototyping, and then it is used to fabricate the tool that will be used to fabricate the product. So we have one more step in indirect tooling, and we can see here this item is the sacrificial model that will be used to create the mold on this shape, and then the mold will be used to obtain this that is a final product made by I think composite materials. Then we move to the third market segment that is called digital manufacturing, also called direct digital manufacturing. And what does it mean? Well, we can say that according to American Society of Manufacturing Engineering, direct digital manufacturing refers to the process of going directly from an electronic digital representation of a part, so going from a 3D model directly to the final product by means of additive manufacturing. So the result of the process in this case is not a prototype, is not a tool or molds to obtain a product, but is the product itself. So what drivers for direct digital manufacturing we can underline? There are four main aspects. The first is the ability to use 3D printing to optimize the geometry of final parts, often saving raw materials in the process. Second, make parts with geometries that could not be created by means of traditional approaches. Third, make low run that would be not cost effective to manufacture without 3D printing. So if I have a small batch production, so a small number of items to be done. So finally, to improve sustainability by means of localization of production. As I told, I don't need to produce all the items in the same factory and then move by means of transportation, but I can send the digital model of the product, and the product could be 3D printed locally near the effective place where it will be used. As example, this is a seat belt buckle in not I think not recently, but in airplane flyers we usually use this kind of seat belt to assure our set, and this company was Airbus, provide this new technology just to save weight. It's a small saving weight, but if we multiplicate this small value per the number of seat belts buckles in the airplane, it is an important number, and that means saving fuel for the company. So this was a process of redesign the product to optimize the geometry of the final part. Finally, we move to personal fabrication. Personal fabrication, we can see some examples that remind the examples I showed you before as the output of the digital fabrication processes, but we are moving in the same direction. 3D printing will increasingly allow products to be customized according to our tastes or personalized according to our individual characteristics. So, two aspects, customization and personalization. What is the difference? Customization is the action of modifying something to suit a particular individual taste. So I'd like, this is an example of a guitar, I'd like maybe a pattern for the surface. I'd like a particular shape, and this kind of customization usually is performed directly by the customers. The customer can modify the products according to its taste. For what concerns personalization, instead, is the action of designing something to fit specific individual characteristics. That means that the design is tailored, for example, on my anatomical shapes. Okay, so this aspect is usually performed by designers and is mainly used for what concern the biomedical fields, for what concern also fashion, also jewelry. If you want to provide some technology, some results, some products that completely fit the shape of the customer. So we can say also this kind of revolution now from the point of view of the manufacturing paradigms. We have seen the 3D printing revolution stepping from different market segments. Now we'll have a look to the revolution of the manufacturing paradigms. Manufacturing enterprises are involved in three main activities: design, make, and sell. This is as reported by in the paper of Joran Korem in 2010, the global manufacturing revolution. These are the main activities: design, make. We have always talked about that, the design and manufacturing processes. Also, sell, of course, is an important activity that manufacturing enterprises have to face with. And the relationship between these three activities is able to identify specific manufacturing paradigms. So, different order of these activities change the model of manufacturing. The craft production, we have sell, design, and make. The artisan, for the first step, sell the product to the customer, then move to design it, and finally is able to make it. For what concerns mass production, we have the design step, that is the first one. Then we have the manufacturing step for the production of a big amount of items that are all with the same shapes and so on. And then we have to sell, try to sell all the items that we have product. Then the mass customization, there is another order in this activity, that is design, sell, and make. So mass customization allow the manufacturing to process it after the product has been sold to the customer, because the customer has the possibility to customize the product itself. So if we have a look to the this graph in which we have the product variety to get mapped on the product volume per model, we can see that starting from craft production, we moved to mass production, and then from mass production we come back to mass customization and moving towards personalized production. So there is sort of a circle in these manufacturing approaches, and we can have also an idea of the time when the change of model have been activated, started in during the years. Of course, all these business models of manufacturing approaches are related to manufacturing systems and manufacturing technologies. So craft production, it was supported by general purpose machine tools, the machine tools of the artisans. The mass production was supported by dedicated manufacturing lines, so assembly lines and so on. Mass customization is supported by flexible manufacturing lines. And finally, personalized production is supported by reconfigurable manufacturing lines, and also by technologies such as 3D printing. So we can see craft production, mass customization, personalized production. And we can see that both from the point of view of the 3D printing revolution and from the point of view of the manufacturing revolution, the last step faced with personalized production. So we have also pictures that show how the customer is involved in the process, and we can see maybe better in this other slide, in where we can see the different models: craft manufacturing, mass customization, and the direct digital manufacturing. We can see how interact all the stakeholders of the process: consumer, artisan, designer, workshop, factory, local production, and so on. So these are schematic representation of how this kind of modeling of models of manufacturing move. So come back to the title of the presentation: continuous mass customization process. What does it mean? Continuous mass customization is an evolution of the discrete approach of mass customization. We can see mass customization as the possibility of developing a wide number of items such as in the mass production approach, but with the possibility to customize this kind of item, such as in the craft production capabilities. And the next step is to try to perform a continuous mass customization. What does it mean? Now, in which context we are moving? Now there is an increasing number of consumers, of customers that are moving to online market with new expectations, with new needs, and also with a new approach to the product. These customers are mainly informed about products and have an increasingly awareness of about these products. So product customization is a continuous growing trend. So customers always need something that is as much as possible tailored on his taste, on his shapes, and so on. And how this kind of process can be supported. The mass customization process is nowadays carried out through interaction of the consumer on a web interface that can allow him to customize his product. So the user is directly involved in the design process, and that is why we have seen different schematic representation of the stakeholders in the different processes of manufacturing. In this case, the role of the customer is an active role that allow him to directly collaborate in the design steps. But mass customization go to just a combination of modular components that are already made. It is not possible for the customer to redesign to the shapes of the object. You can just choose from a number, a discrete number of available versions, available solutions. Product customization is limited by the number of component combinations, so I'm not able to do what I would like to do, maybe. And consumers do not actively participate in the development of the product itself. You can just choose a combination of pre-existing components. So it's not emotionally involved in the creation of this kind of object. So the idea is to move from mass customization to continuous mass customization. This is a clear example for what concerns a color product matrix, a palette of colors. In the first case, we can choose between thin, discrete numbers of colors. In the second case, we can decide the code, the RGB code of the color, so we don't have any limitation in the choice of these particular features. Which tools we need for continuous mass customization? Well, for concern design, we need generative interactive modeling tools that allow the consumer to collaborate, to participate in the design process without, of course, any specific 3D modeling skills. We cannot expect that consumers are particularly skilled in 3D design. So we need to provide tools that allow the interaction, but without the need of particular skills in doing that. For what concerns manufacturing, of course, we come back to the things that we have talked about in this session. The first aspect is the flexibility of the production that can be obtained by means of 3D printing technologies, for example. It is important to access to a wide variety of materials, but we know that for what concerns also 3D printing technologies, there is very rapidly growth of in the numbers of available materials that we can use for this kind of technology. And also in this process we can also add, we can also input non-standard data such as anthropometric measurements, such as physical data and so on. This for give answer to the request on personalization. So the consumer, the customer can interact for what concerns the customization aspect, and the designer can input some anthropometric data, for example, for the personalization aspect of the product. So benefit, the customer is actively and emotionally involved in the process. Greater is the commitment of the prosumer. It's not more a consumer, is also a producer, so a consumer that is an active role in the choice of design, and so can have great satisfaction. It can have an identity. It can feel identity with the product and so on. We can create links and connection between the consumers and the products, the consumers and the companies. We can reduce the cost in market research, because I don't need market research, because it's the customer itself that is involved in the process of the design. Of course, I can also have a verification of what are the market needs, because I have the different feedback, continuous feedback for customers, and I don't need product stocks. The idea is an approach make to order instead of make to stock. So it's completely change the paradigm. Of course, there are also some critical issues. First, well, we said that is continuous mass customization, so we can state that we don't have limits in the possible choices that the customer can make. But it is important, it is necessary to define a limit to avoid the risk of increasing the indecision of the consumer. If I have too many variants, it's not easy to choose the right one. The company must understand what is the price that we can add to the product, at the price that the customer can accept for the customization of the product itself, and the delivering time must be short as possible. The idea is move from order to delivery very quickly. There are also some internal critical issues that means I need some design and manufacturing processes that needs to be more efficient with respect to the traditional ones. And also I need to set up a fast supply chain to quickly delivering the product once the customer has finished the design step. So I just want to give you some examples that are specifically targeted on creative and cultural heritage, creative and cultural industries. This project is called Shape It, Forge Your Music, and this project was developed in a generative art hackathon. The idea is to move from music to shape. So how what is the main process? Well, the idea is that music is a sensory phenomenon that can affect people's emotions. So why we don't translate this emotional vibration into something physical? So the idea is to pass from the music that I like to an object that is representing that music. So the project was based on this mission, moving from audible to wearable. Audible means we don't have a standard content because each consumer can choose his favorite song. This song is elaborated from this audio. There are some design rules are extracted. These design rules are used for design a wearable bracelet that is custom shaped based on the input of the soundtrack. This is just a schematic picture of how this project was developed. We start with a soundtrack that is chosen by the customer. These data are extracted by means sound pattern tools for analysis of the sound, and by means of a neural network that is able to identify the kind of musical song. So we can extract both generic information such as the kind of the genre of music, but also univocal information extracted directly by the soundtrack. These data are pasted to Grasshopper and Rhino, that are software for computer-aided design that uses VPL, visual programming language, to design the shapes. So in this case, we do not directly design such as in a traditional way, but we design the process that will allow to build the final shape. And this, for example, as the results of the application of this process to different kind of music, passing from metal, pop, classic, and electro. So different input. In this case, the input was a song, and different output, and in this case the output was a bracelet for that is strictly connected with the emotional sensation of the customer. So finally, just to show you something that can be interactively modified, I try to reproduce the four manufacturing paradigms that we have seen by means of a very simple example, by a very simple case study that is an example of a vase. Well, the first craft production in this picture, typical example of craft production with a potter that is shaping, that is molding a vase within the typical pottering wheel. So there is, I think, most classical representation of a craft production. We can move from this kind of approach to the mass production approach. In this picture, we have examples of the same vases, the same vase in huge number of items. All these objects are the same, so the same manufacturing process, the same shape, the same material, the same color, the same dimension, the same size, and so on. So this is a classical mass production approach. Then we can move from a mass customization. Well, really is not an heavy customization in this picture, but we have, for example, a customization color in the letter, so we can put some pictures. We can choose and move from between different variables, possibility, different versions. And what next? We have seen the first three manufacturing paradigms. What is the next paradigm? This picture, I think, that can really represent this approach in personalized production. We are always facing with vases. This is, I think, also an interesting project, because the idea is to use empty plastic bottles in a beautiful way. So with this customized cover, we can cover the plastic bottles and use it as a vase. So we can say we have the same plastic bottles inside, but different cover shapes that can be customized. So I tried to just to show how this kind of technology can be interactive between the designer and the user, the design and the customers. Here you can find this link. If you try to go to that link, you will find that these windows with this is a simple vase with some parameters that you can find on the right. And by moving this parameter, you can modify the shape of the vase. The vase is very simple because, of course, if you move to complex geometries, we need a computational time that is that could need different seconds to redesign the shape. But this just to have an idea on how this kind of technology will No, I'll try so to I have, okay, here. Okay, this is the active Windows, so I need to move and as you can say, you can move the object. Is very simple, but by moving this parameter, you can interactively change the design of the vase. So you can move and in this way, we can see that we don't have just one vase, we don't have a discrete number of shapes, but we have all the possibilities. So in by means of this kind of technology, anyone is able to customize his product, so to be engagement, to feel a strong commitment in the design step, and this can of course allow a complete customization process. So this I come back to it's not this one. Okay, I come back to the presentation, but just to going to close the second part, I also give you some other examples of products that can be customized. So it's very simple. So also to check, to move, to try to design or customize, modify the design of these simple objects, and this can be done without any specific skills in design. So okay, also in this case I give you some reference, and of course if you have some more questions about this second part, you are welcome, of course. Thank you very much for your attention.
Thank you, Massimiliano. Okay, any question? No. Okay, I would add to the thing that Roberto wrote before. How is this useful for CCI sector? I think it would be the most crucial part. I'm sure it is, but you'll have to specify it a bit more or simplify it a bit in outputs that people will see that, okay, this is the future and it can be used and it can be done even for smaller creatives. So I think that would be the main goal for you to present in outputs.
Okay, of course.
Okay, Francesco, I think now it's your turn. Sound on.
Sorry, I will be brief. I think we do not have so much time.
Yeah, I mean,
okay, really brief. So,
yeah.
No problem. I'm going to answer your question and the question of Roberto. So
okay.
What about cultural and creative industries? Yeah, I would like to share my slides, and I will be really brief and concise.
You need co-hosts, yeah.
Yeah.
Oh,
Thank you.
Yeah, done.
Thank you very much. Okay, you can see my slide now.
Yeah, all good.
Thank you. Perfect. So directly to my case study, because maybe this is interesting for understanding the connection between digital manufacturing and cultural and creative industries. So this is My Mini Factories is a really, really interesting platform and community, because my argument is C2C online communities and platform for co-designing and co-production of new products, innovation and projects, creative projects, and so on. I have called these platforms C2C because there is some theory behind, but we can discuss this another time. It's interesting simply to understand that these are not professional networks or social networks. Actually, these are hybrid networks, and these networks mix together social aspects like interaction, relationships, and so on, and business aspect of production. These are perfect. These community are perfect for small producers, small artists, designer, and so on. And they are really, really open to different creative figures and with different background. For example, okay, makers, engineers, illustrators, creatives, and so on. So, My Mini Factory. This is the central page, the main page. You can see in the Explore, in the little window, you can see all the possible application of 3D printing to cultural and creative industries. So we have fashion and accessories, jewelry, education, architecture, gadget and electronics, toys and games, board games, fan art, home and garden. So really, really interesting to see all these opportunities. For example, what is actually interesting is the opening of new market, for example, in the field of fun and passionate, for example, about, well, I don't know, films, about comics, about board games, about online games, and so on. So this is interesting because actually this platform allows you to choose your own or to choose a model, a 3D model, and print your 3D model in the nearest 3D printing fabric or Fab Lab, because this is a distributed ecosystem. So you can find what is the closest Fab Labs to your home. Then is interesting because you have many tools for artists and for designers to finance and sell their products. So there are crowdfunding tools that allow you to promote campaigns and fund your initiative or artistic projects and so on. So you can see Nebula, for example, is a Shifai miniatures for, I think, board role play game. And there are also competition to engage artists and the community in interaction that has gamification aspect, for example. So this is to push interaction in the platforms. There are you can see this is the crowdfunding platform. This is interesting to see how competencies actually and tools are all mixed together in these platforms, because there are social aspects, as I said, and business aspect as crowdfunding. So when we talk about competencies, for example, it is really interesting to understand that to take part to these platforms and communities, it is important to have different competencies. So artistic competencies, technical competencies, because you have to be a good designer, of course, a creative designer, of course, but also a designer that is able to interact with consumers, with passionate, with followers. Also, you have to be able to manage a crowdfunding campaigns, because if you have a big project and you need big money, of course, so you have to you need competencies to plan, launch, develop, and manage a crowdfunding campaign. That it is not easy. Also, you have to interact, to listen to comments, for example, to put updates. So we know that crowdfunding is quite complex process, but it's interesting how all these elements are mixed together in this platform. So as I said, this is no professional, totally professional platform. So this is not a B2B platforms. Is an hybrid platform. That's why I call it a C2C, consumer to consumer, or user to user, or user to consumer, or business to consumer, and so on. There are many different different relationships and networks that you can create, interact within, and take part to in these platforms. So these are competition. There are micro and small businesses that are interested in engaging artists and designers in competition, in contest, to have, of course, modeling and the products and draws and so on. And that's interesting too. And contribute, this part is interesting also because these are other tools that are useful to engage the community at large. You can see ideas, fresh uploads, and help curating pictures. So there are many elements to be interactive. If you remember, Massimiliano has talked about the direct digital manufacturing. So this platform allows direct interaction between a network of actors that actually can collaborate. There is the opportunity to create a network to collaborate for the production of new products, really. So only this is interesting because line for future development, education. Here it is. For example, education is a really interesting future line, in my opinion. Okay, I'm happy to show you this specific sector. And you can see that with 3D printing, you can elaborate so many ideas, there's so many new products, useful products for education and training. That is our argument. So, but of course, here, these are applied to biology, chemistry, design and technology, and so on, and also arts and, for example, heritage, I think, and other. There are many possibilities in these technologies. So the rest is that was my presentation. This is the closing. This is a bit interesting because here I'll talk about actually competencies. What are the competencies that are actually needed and that we can put on the handbook and on the platform, of course, that can be used and acquired by professional and cultural operators. So these competencies are relational, networking, and marketing competencies, because if you remember, Romagna Tech is involved with process. So we talk about manufacturing process that is actually changed, or there is an opportunity to change it with these technologies, and networking. So there is the social business part. I mean the marketing part of the story. And networking is a real interesting, important, and primary capability in this sense, because networking opens you the possibility to enter networks and communities. And when you enter networks and community, and you are a small producer or a freelancer or a self-employed entrepreneurs, these are powerful contexts where you can find resources for your activities, and you can learn and train new competencies. Also, you can open new markets, because it's interesting to understand that in these platforms, the community is also a door for a new market, because followers, for example, or passionate, or persons you interact with, are the first customers of your work. So, or you have to be able to make this person become your first customers, or you can engage development project with customers, with passionate, with consumer, and so on. So these platforms are quite complex, And maybe networking is one of the most important competence you have to put into use to orient your work and develop your business and career. And so that's all. Thank you very much. I was very brief because I know we are a bit late. So thank you. If you have questions, yeah, I'm really happy to answer you. Hope I have answered to Roberto and Jan for what is concerning potential application of these technologies in cultural and creative field.
Yes, thank you very much, Francesco. Very interesting.
It's interesting also to search for example, cosplayer. If you know, cosplaying is a really crazy application because there are many passionate fans about. Okay, I just said movies and so on that create unique product like mask, armor, and to turn in a superhero and so on, or anime and so on. But all these people are potential customer for these applications. And of course, there is a real important creative work behind these processes. Thank you.
Okay, thank you, Francesco.
Thank you.
Like we said before, it would be very helpful if you could prepare those handouts for those three models that you and Massimiliano presented today. By the end of next week would be fine. So yeah, that would be all for today. Thanks to Romagna Tech for breaking the ice and to be the first that finished the first day of our 5-day training program. On Friday, it would be Kekorama to present their part, and then on Monday it would be us. So we will be seeing quite a lot in the next week. So be good, enjoy the summer, and yeah, we'll be in touch through mails if everything.
Let me just take a screenshot.
Yeah,
of all of
of
us.
course.
Okay. Okay. One second. Okay, one more, just to make sure. Okay, done. Thank you.
Like Joanna said before, share it through your socials. So that we will boost a bit our base for the SME project. Okay, that will be all. If anyone have any questions? Otherwise, stay safe and see you on Friday.
Bye.
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 Thank you very much. Bye.
Bye. Thank you very much. Bye.
Thank you.
Yeah.
Bye.